Welcome to Summarize Science. Have you ever used a book to prop open a door or a shoe to hammer a nail? This ability to improvise with tools is something we humans do without thinking, but it's a huge challenge for robots. Today, we're looking at a fascinating paper from researchers at Stanford and UT Austin called Get Use, which teaches a robot how to make the best of what's around. Most robots are taught to use specific tools for specific tasks, but what happens when the right tool is missing? They're often stuck, unable to identify and use a substitute from a pile of random objects. The Get Use method, shown here, tackles this problem with a clever two-step simulation-to-real-world approach. First, everything happens in a computer simulation. Instead of just giving the robot pre-made virtual tools, the researchers let it build its own from scratch. As you can see in this diagram, the robot attaches simple elements or blocks to its wrists, trying out different shapes through trial and error to solve a task. For a sweeping task, it might build a long, flat surface, and for a hooking task, it builds something with a curve. This process teaches the robot the fundamental geometry that makes a tool effective for a certain job, not just what a specific tool looks like. It's learning the why behind a tool's shape. Once the robot understands the ideal shape of a tool, this knowledge is transferred to the physical robot. Now, when the real robot looks at a table of objects, it doesn't look for a sweeper, it looks for an object with a good sweeping shape. This image shows how the system ranks different objects based on their suitability for a task, with one being the best choice available. After selecting the most promising object, it then figures out how to grasp it and use it to complete the task. The researchers tested this on a real bimanual robot with 3 challenging tasks: sweeping, hooking an out-of-reach object, and decanting, which involves scooping and pouring. They used a wide range of objects, including both useful ones and distractor items, to really test the robot's selection skills. The results were impressive. The Get Use method outperformed existing approaches by a huge margin, with 30 to 60% higher success rates. This table shows just how much better it performed compared to other methods, many of which scored 0. So, to recap the key points, the robot first learns ideal tool shapes by building them in a simulation. Then, it uses this geometric knowledge to select and use the best available real-world object as a tool. This is a major step away from simply memorizing tools and towards a more general, problem-solving intelligence. What could this mean for the future? Imagine household robots that can tidy up using whatever they find, or factory robots that can adapt on the fly if a specific part is missing. This kind of flexible, generalized tool use is a cornerstone of versatility and could make robots far more capable in the unpredictable real world. That's all for this episode of Summarize Science. Thanks for watching.